High up in the northern sky, there's this incredible celestial dragon that, well, it never sleeps. This is Draco, and it's so much more than just a random collection of stars. It's really a time capsule. I mean, it holds the secrets of the ancient pyramids, the very first proof that our planet is in motion, and, of course, a timeless myth of an epic battle. So let's dive in and explore the dragon in the stars.
You know, if you're in the northern hemisphere, you can actually see Draco any night of the year. It's what we call circumpolar, which is just a fancy way of saying it never ever dips below the horizon. It just circles endlessly around the Little Dipper, almost like an eternal guardian. And that whole idea of a tireless watcher, that's a really key part of its story.
All right, first up, let's zoom in and look at some of the individual stars that make up Draco. Because a few of them, well, they completely changed how we understand our place in the universe.
We all think of Polaris as the North Star, right? But that hasn't always been the case. So here's a question for you. Who was the North Star for the builders of the pyramids? The answer, it turns out, isn't in the Little Dipper at all. It's right here in Draco.
Almost 5,000 years ago, right when the Great Pyramids were being constructed, the North Star was a different star entirely, Thuban, found in the dragon's tail. And this is incredible. The builders actually aligned the pyramid's entrance shafts to point directly at Thuban. They saw it as a kind of celestial pathway for the pharaoh's soul to the heavens. And get this, in about 19,000 years, Thuban is going to be our North Star all over again.
So why does the North Star change? What's going on here? It's because of a phenomenon called axial precession. The easiest way to think about it is to picture the Earth like a spinning top. You know how a top doesn't just spin perfectly upright? It has that slow, lazy wobble to it. Well, the Earth does the exact same thing. This wobble makes our North Pole point to different parts of the sky over thousands of years. One full wobble takes about 26,000 years, and during that long cycle, different stars get their turn in the spotlight as the North Star.
Okay, now for Draco's brightest star, Eltanin. And this star is a huge deal. It's not just bright, it's the star that gave us the very first concrete, physical proof that the Earth revolves around the sun.
So back in 1728, an astronomer named James Bradley noticed something really strange about Eltanin. He saw that its position in the sky seemed to shift just slightly throughout the year, but not in the way he was expecting. He eventually realized he was observing something called the aberration of light. Here's an analogy. Imagine you're walking in the rain. Even if the raindrops are falling straight down, you have to tilt your umbrella forward to keep from getting wet, right? That's because you are moving. In exactly the same way, we have to tilt our telescopes ever so slightly to catch starlight because our planet is constantly moving through space. This observation was the first hard evidence of Earth's journey around the sun.
So we've met some of the key stars. Now let's pull back a bit and look at the shape of the dragon itself.
The easiest part of Draco to spot is definitely its head. It's a distinct four-sided shape, often called the lozenge. These four stars, Eltanin, Rastaban, Grumium, and Kuma, come together to form the piercing eyes and powerful jaws of this celestial dragon.
Let's just zoom in on one of those stars for a second. Rastaban. This thing is an absolute monster. It's a yellow supergiant, and it shines 950 times brighter than our own sun. To give you a little perspective on that, if you were to swap our sun with Rastaban, it would completely swallow the entire orbit of Mercury.
But you know, a dragon's head isn't the only thing people have seen here. For ancient Arabic astronomers, these exact same stars told a totally different story. They saw four mother camels standing guard, protecting their young from a pack of attacking hyenas. It's just a beautiful reminder that the pictures we trace in the sky are really a reflection of our own cultures and stories.
Now, because of where Draco is located in our sky, looking at it is kind of like looking up and out of the flat, dusty disk of our own Milky Way. And what that does is give us this crystal clear, unobstructed window into deep space. And wow, is it packed with some incredible sights.
One of the true jewels in Draco is the Cat's Eye Nebula. And what you're seeing here is essentially what the end looks like for a star similar to our sun. As the star died, it puffed off its outer layers one by one, creating this unbelievably complex web of gas shells and powerful jets, all of it lit up from the inside by the star's tiny, hot, dying core.
The funny thing is, it's called a planetary nebula, but it has absolutely nothing to do with planets. Back in 1864, the cat's eye was actually the very first one to be studied with a new technique called spectroscopy. An astronomer named William Huggins analyzed its light and made a truly shocking discovery. It wasn't a collection of distant stars, it was a massive cloud of glowing gas. This discovery completely rewrote our understanding of how stars die.
Next up, we have the spindle galaxy, and this object is a perfect example of how your point of view can change, well, everything.
The spindle is what's known as a lenticular galaxy. From our little corner of the universe, we just happen to see it perfectly edge-on. So instead of a grand swirling spiral that we're used to seeing, we see its disk as this razor-thin slice of light. And that dark line you can see cutting right through the middle, that's a massive lane of cosmic dust, and it's what gives the galaxy that classic spindle shape.
And Draco's wonders really don't stop there. I mean, you've got the Tadpole Galaxy, which was ripped apart by a cosmic collision, and it has this tail of stars stretching for 280,000 light-years. There's also the Draco supercluster, a literal wall of thousands of galaxies. And there's even a star in Draco, HIP 56948, which is the closest twin to our very own sun that we've ever found. Now that we've gone through the science, let's turn to the myth. Because for the ancient Greeks, this winding constellation wasn't just a collection of stars, it was Latitudes, one of the most fearsome monsters in all of mythology.
The story goes that way out at the edge of the world, there was a sacred garden with a tree that grew golden apples of immortality. And to guard this priceless treasure, the goddess Hera set a truly terrifying watchman, laid on, a 100-headed dragon who never ever slept.
So for his 11th nearly impossible labor, the hero Hercules had to steal these apples. But how on earth do you get past an unkillable 100-headed dragon? Hercules knew he couldn't win with brute force alone, so he used his wits. He went to the Titan Atlas, who was stuck holding up the sky nearby. Hercules made him a deal. He offered to hold up the sky for a little while if Atlas would just pop over and grab the apples. Atlas agreed. But when he came back, he tried to trick Hercules and leave him holding the sky forever. Hercules played along. He just asked Atlas to take it back for 1 second so he could adjust his cloak, and the moment Atlas took the sky back, Hercules snatched the apples and simply walked away.
To honor her loyal guardian, the goddess Hera placed Latitudes' image among the stars, and its position in the sky tells the whole story. If you look right next to Draco, you'll find the constellation of Hercules, and his foot is planted firmly on the dragon's head, an eternal, celestial reminder of his victory.
So you see, Draco is so much more than just a simple pattern of stars. It's a historical clock, pointing us all the way back to the time of the pharaohs. It's a cosmic physics laboratory where we first proved how our own world moves through space. And it's a mythological monument, telling an ancient story of heroes and monsters for all time.
Which really just leaves us with a final question to ponder. When we look up at the stars, are we really seeing a map of the universe? Or are we actually just seeing a mirror of ourselves? Our history, our science, and our greatest stories all written across the night sky.